Let's talk about clippers. Now, a very specific point I want to make about the clipper is, yes, we can use it in mastering. We can also use it on separate tracks. And once I explain to you the nature of it and how it stacks up against a limiter, you'll pretty much get the idea of which kind of circumstances call for a clipper, when the clipper is preferable solution. Now, a clipper, just like that, let's say a hard clipper. Let me just make that. Okay, so a hard clipper is basically going to stop the signal at a clipping point, at a threshold, basically, as you can see. It's going to stop the progression of the signal, not unlike a limiter, unlike a brick wall limiter that we talked about already. So it's just going to stop the sound in its tracks at a certain level. Now, where it differs from a limiter is that attack and release is how fast it starts and stops affecting the sound. And that attack and release and all those program dependent settings for it, all the automatic stuff that happens behind the scenes in a limiter is what's really important for a limiter today. It's why they sound so transparent, why they're getting better and better, is that setting they have behind the scenes where they, alongside with the settings you made, also have an additional program dependent, so that they react to the actual source signal differently in order to make them more transparent, louder, less distortion, all of that. Now, a clipper is going to stop the signal in its tracks at a threshold, and I can show that to you on a sine wave. Let's play a sine wave. I'm going to lower the threshold until it reaches that red point. You'll see that it starts clipping. You see that? It stops the signal in its tracks. Now, as you see, unlike a limiter, it will produce all of these harmonics. And of course, it acts quite differently on a sine wave, but a sine wave is just the most graphical thing I can use to show you what it looks like. Now, that's hard clipping. Okay. And just to get straight to the point, when I would use this is maybe on some really short transient peaks I want to stop. Now, you might ask yourself, like, why wouldn't I do that with a limiter? Well, a limiter is going to react to a really short peak transient with also the same, release setting. And it will cause pumping longer than it needs to for such a short transient. You might get a much better result by cutting short transients, really short peaks in your signal using a clipper. It might be much more transparent to cut it with a clipper. Now, what happens? Well, then you might ask yourself, well, why don't we use the clippers then and not limiters? Well, a clipper is going to produce distortion much quicker. Meaning that once you use a clipper, the amount of gain reduction you can do, the amount of gain reduction you can do on certain frequencies as well is much smaller than what you can do with a limiter. Because the limiter does have those, program dependent settings and reaction times, with the attack and release. A clipper does not have those. So really short transient peaks, better off with a clipper. Anything else program material that you want to limit, but you need that attack and release to, react to the music so it doesn't sound that squashed or pumpy or, affected, so it's more transparent, then you need a limiter. Now let me show you the difference between that hard clip, as you can see right here, a hard clip, or a soft clip. Let me go to a soft clip like this. So as I increase this softness, you can see that that knee is getting softer, almost like a knee in a compressor, although it's quite different because a knee in the compressor would start right there. It would lower that sharp edge downwards. Right here, we're just, as you see, lifting up the low level information. Just like that. So we are lifting that up and we are smoothing out this transition into the clipping, into the, complete stoppage of the signal at a certain point. Just like that. You can see it on the actual graph. Now, let's try that change. Let me play a note. And let's try to change, like right there, let's try to change that into a soft clip. You can see what's happening with the sine wave. And you can also see that it's a different harmonic content as well. So you see that edge is now softer. So the edge leading from unclipped into clipped material is now softer. It sounds softer, as you could see. saying soft clip. Well, it does look like a soft knee here. It sounds softer because the amount of, the harmonics all the way up there are not so many. So it does sound softer. It looks softer. It is a soft clip. And we would use this as well to raise the apparent volume. So this is basically a saturation of a kind. Okay? We are saturating the signal. We are bending it. And you can see that we are raising the low level information and the high level information as it's approaching that zero where we're going to stop it in its tracks is kind of bending. So we are saturating the signal. Now let's try that on some music. Okay, I'm going to move this aside, maybe just make it a tiny bit smaller, just right there. Let's play it, solo that. Let's try this. I'm going to slowly start lowering. Let me leave that 50%. I'm going to slowly start lowering that clipping level. Look at that. And you can see in red right here the peaks that we have clipped. Okay, I can zoom in here to, let's say, 3, and you can see exactly when it's clipping, it moves. Yeah, that's the clipping happening. Everything before that is actually bending the signal slowly. So let's try it without that. Let me try to just bypass it. Go to my master track. Just a second. Okay, let's try to bypass it. As you can see, the difference is just the song getting saturated, yeah? We have way more content that was low level. We hear it much louder. The song sounds, well, basically more saturated with sound. And on top of that, we have cut off quite a few of those pesky, short transients that are there. And that only means that our limiter that we can place right after is going to have a much easier job with limiting. It means that the transients that we had that could have been loud, let's say a couple of dBs loud, like 3 or 4 dBs loud, and were really short, those are not going to trigger our limiter so that it reacts in such a way so that we hear pumping. Okay, so now the clipper is getting rid of those really short transients, not too much of it, of course, we don't want to induce distortion. And after the fact, we can apply limiting, which is going to be much more transparent. We can push it further. We can make the song even louder without inducing distortion. And also because the clipper is helping with those short transients without inducing too much pumping. So basically that would be one of the best uses for a clipper on the master track. Now you can use that separately on, let's say, groups, on buses, for, I don't know, whatever you can think of. Synthesizers that have really pesky, peaks just like that, or some drums, whatever you can think of that has those short transients that need to be cut off, and that you maybe also by using soft clipping also want to saturate. So make it all over, louder in RMS, louder in actual loudness, but you want to make it lower in that peak value. Now, to just explain to you what I'm looking at here, this is our transfer curve. So you can see that the signal, when it's all the way at a minimum, when it's a hard clipper, it means that up to that point where it's actually minus 6.2, where it's actually clipping, up to that point, everything's linear. So we're not affecting the signal at all. Whatever comes in, comes out the same volume. So to say, if this is the input and that's the output, if we come in at minus 18, we're going out at minus 18. If we come in minus 12, we go out at minus 12. Come in at minus 6, go out minus 6. Now, let's say we came in at minus 3. Let's say somewhere right here in the middle. Let's say we came in at minus 3, would go out minus 6. So at minus 6, everything stops. Any kind of progression in amplitude stops, as you could see on the graph. Now, if we soften that up, you can see that now it changed. So it means that right here, if we come in at minus 18, it will come out a little bit louder. We are raising the floor. We are raising that low level information. And as we are approaching the maximum of that minus 6, where we're going to stop everything, it's slowly bending, starting to slowly, compress the sound into that clipper. Of course, this is happening with no attack, no release. Now, another thing that's really important, and I really love this clipper, is I can see it working. I can see in real time it actually, when it clips, moving. So like this. See, I can see it clipping. You see, we stopped this clip, this short transient. Yeah, that would have been really hard on our limiter. And now it's not. And let's say we can now limit even more. And you can see that it's quite balanced how much we have to, limit. It never has any of these clips that need to be affected. Now, let's try to remove that standard clip and see what the difference is. Now, this standard clipper, by applying this soft clipping, we are raising the level. So I'm going to lower the volume by, let's say, how much? Something minus, 0.8. You can actually see right here that we are raising the overall volume of it, not by 1 dB, but a tiny bit less. So I'm just going to keep it right there. So we have kind of a reference without the change of the volume, like this. You can see how much more limiting we have to apply because we're not clipping like before. And also we're not saturating that much, so the level, look at that, minus 3.9 we had to do. That never happens when we have the clipper on. That means that I can push this limiter even further. Okay, not that much. Let's say even this much. Beautiful. So keep that in mind. You can use the soft clipper if you want to induce some saturation as well. If you want to raise the low amplitude information. If you don't, you can use it as a hard clip, which basically just makes it, straight linear until the clipping point. It was almost the same as doing this. So if you use the hard clipper, everything stays the same until the point of the clipping where, all the transients that you want to just cut off get cut off. Of course, then the volume would not change. I would just reset this to 0.